sure that we are typing things in correctly once we know what formulas to use. Okay. So first, the definition for an annuity is just the sequence of equal payments made at equal time periods. The value of the annuity is basically the total in the account. So all the deposits that you make plus any interest that you earn. Okay? So if you're ever asked to find the value of an annuity, it means find the grand total. Okay, so we'll work through a couple of examples so you can see the different ways that this works. But let's start with example 1. And before we get to the complicated formula, we're going to do this the way we've done already. So $1,000 is invested at the beginning of the year. At the end of the year, we get 10% interest. So using the formulas from section 8.3, I'm just doing P1 plus R to the T. The principal amount is 1,000. What's the rate? 0.10. This is just for 1 year. What do we get? This part's easy. What do we get at the end of the first year? Juliana, what are you getting? Yes, what are you getting?
I got
1,100. Okay. Good. Part B. We're investing $1,000 at the beginning of the year, but we're interested in what's happening at the end of the third year. So let's do this year by year. So at the beginning of year 2, I have $1,100 to start the year, right? Because I just collected my interest. Yay, $100. I'm also depositing $1,000. So now what is in the account? 2,100, 2,100, okay? So now this amount collects interest at 10%. And now my account would be what? So 2,100 times 1 plus 0.10, just like we did above, but starting with a different amount now. What is that? $2,310. Great. So now at the beginning of year 3, how much money do I start with? It's $2,310 plus, I'm always depositing $1,000, right? According to this problem. So now I have $3,310. And now that gets interest just like the previous amount at 10%. And so now what is my grand total after 3 years? $3,641. Okay. So that's just kind of how it works. There's a lot of calculation, recalculation that goes into this, because it's not just you put in $1,000 and let it sit there for however long. You keep putting more and more money in. And typically, you guys, it's not even just one time a year, especially if you have when you have real jobs when you guys are older, you'll take money every paycheck and put it into this account. So it'll actually be 24 deposits. If you get paid twice a month, you get 24 total deposits a year. Does that make sense? I think most of these problems, though, will be working either quarterly or monthly. So still the same idea, but you'll actually have more and more calculations to do. we're not going to do this year by year because it gets pretty long and it gets, it's a lot of work. If we were going to do this for 30 years, I don't want you doing this 30 times to get the answer. Okay? There are formulas that we're going to be able to use. Okay? Actually, let's go ahead and just get to it. So I'm going to skip this part. This is just more to illustrate kind of how it works when you deposit money in, then you get more interest, and then you deposit another amount, get more interest. You guys don't really, I don't think you guys have done geometric series before, right? So to show you where the formula comes from kind of would be pointless because I'm not trying to say you wouldn't understand, but you haven't learned some of the algebra that you would need to do it. So I'm just going to kind of show you I hate kind of doing that where I was like, here's the formula. It's not magic. If anybody really wants to see how it works, I can show you where it comes from. But here's what we're going to do. We're just going to write down, I'm going to start with the most important formula, which is going to be this one here, compounded n times a year. And that one's going to look like this. So this is correct because with all the right letters, just formatted weird. Here's what it should look like. Future value of the annuity is going to be P, that's the deposit amount. Everything's kind of written out for you in case you forget, but this is the deposit amount. And then you do 2 parentheses, 1 plus R over N to the NT minus 1, all divided by R over N. So this is how you would calculate how much money you have in an account where you keep putting money in more than one time, like every month, every year. And as long as you know this formula, you don't have to really worry about this, but we'll write it down. So when we did when we did compound interest before, this n represented how many times a year we compounded things, right? If we compounded quarterly, for example, what would n be? 4. What if it was monthly? 12. Weekly? 52. Good. What about if it was just annually? Once. Well, compounded annually, if you just plug n equals 1 into this formula, what's r divided by 1? R. And then down here, r divided by 1 is r again. So this formula gets reduced to what looks like this. Same thing, except instead of r over n, you just have r. And instead of nt, you just have t. If you're doing annually, either one works, yes. But what I'm trying to say is that as long as you know this one, you don't even have to worry about this one because you'll plug in 1 and go, oh yeah, that's just R. Or you'll plug in 12 or whatever you need to. Okay. Example 3 we pretty much just did, so we're not gonna do that because it was explaining how this formula in the pink box comes from this blue box here. Okay? Example 4 though, this is what we're gonna do. And we're going to end class with this. Let's just make sure we do it correctly. So if you don't have your calculators out, please take them out now. Let's just set things up. And then I want to see what kinds of answers we're getting. In the last class, we had like 4 or 5 different answers. I would love if everybody has the same answer right away. That would make me so happy. Or at the very least, if most of us are getting the correct answer. But let's write down what we're doing here. So if you haven't read it, read it real quick so that you know the context of example 4. So at the end of each quarter, we're making a deposit of $12.50. So how many times a year am I depositing money? Okay, so let's write out what we know. The deposit amount is $12.50. And now I'm just gonna plug into this formula that we have up here. So double parentheses 1 plus, what's the rate? 0.08 divided by 4, because n is 4 for 4 times a year. This n times t will be 4 times 30, very good. Minus 1, close the extra parentheses, and we're dividing by 0.08 over 4. Okay, so this is what it looks like on paper. Everyone take a few seconds here, and let's see what we get when we figure this out on the calculator. When you got an answer, check with a neighbor. See if you guys got the same thing. Thank you. All right, let's hear some of the answers. What did you get?
I got 6103, 22.69.
61, so 610,000 and whatever.
6103,
Yeah.
22.69.
Okay, what else? Any other answers? Everyone got that? Wow. Okay, I guess I won't show you the cool thing I wanted to show you, but well, I think I've already shown you, but yeah. So one thing you can do, I heard some of you guys talking about just do order of operation. Absolutely. If you want to do it a step at a time, start in here, figure that out, subtract 1, multiply it with that, and then divide it by this whole thing, right? You should get the same answer. If you forgot or if you don't remember, let's see if I can. If you press the alpha button and then y equals, that gets you to this numerator-denominator template. Alpha y equals. Yeah, you need an 84 or higher. So if you don't have an 84 or higher, just do it a step at a time. If you do have an 84 or higher, this is kind of nice because what you're going to do now in the calculator is make this look exactly like we have written on paper. Okay? So I'm going to just start typing 1250, 2 parentheses, 1 plus, and then I got another fraction, right? So I'm going to go back to alpha y equals, do the little numerator-denominator thing again, and do 0.08 divided by 4. Close the parentheses. Exponent. 4, whoops, 4 times 30. Minus 1. Close the parentheses. And then in the denominator, I have another fraction. So if I go to alpha and then y equals, get that new fraction template in there, do 0.08 divided by 4. And so now this is exactly, you guys see what I'm saying? It's exactly what I have on paper. Okay, and if you do it all at once, you should get this answer. If you do it a step at a time, you should still get the same answer. Okay? But the bottom line is, that's a lot of money. Yes? 610,000. I wish I had that much money. So it's $610,322.69. Okay. So that is how much money is in the account. That's not how much we put into it, though, right? How could I find out how much money we put into the account?
They would put 1,250.
Just $1,250? You're on the right track. How many times did I put $1,250 in there?
Oh, 30.
Was it just 30?
No, 4 times.
Was it just 4?
30.
It was 4 times a year for how many years? 30. So if I take my deposit amount 4 times a year for 30 years, multiply all this out, that's going to tell us exactly how much money we're putting into the account. What is that? 150,000 on the nose? On the dot. Okay, so that is a lot of money, but when you think about it, that's just a small percentage of this amount, right? And this is over 30 years. So this is how much money we're putting in. This is how much is in the account at the end of 30 years. How do I find how much interest I've earned then? Subtract the two, yes. Don't go creative on me and start using different formulas to find the interest. You have the final amount. You have what you put into it. Subtract and find the difference. And what do you get? Juliana, what did you get? Thank you. John, what did you get?
I got 460,322.69.
Okay. That's a lot of interest, right? Okay. That's a good place to stop today. But bottom line,